So in this video, we want to look at transformations of curves, and we're going to look at 6 basic transformations of curves. So I've drawn a function, which we can see here is fx, and it's a simple quadratic. I've also drawn in the vertex of this quadratic because we're going to see what happens to the vertex on each different transformation. So a couple of simple ones. We're going to start off by doing f and then to the minus x. So we can see here that when we do this first one, f and then brackets minus x, we've got a reflection in the y-axis. Now, in fact, rather than saying a reflection in the y-axis, we're going to say that's a reflection in the line x equals 0. And the reason I'm saying that is because I'm actually making the x negative. So I'm doing something to the x rather than the whole function. So let's just take that one away and let's do a negative of the whole function. And when we do a negative of the whole function, hopefully if we turn this one on, yep, we get this black graph here. And what we can see here is that we've reflected it in the line y equals 0, the x-axis. And this is basically, anytime I do something to the whole function, it's going to have a vertical transformation. Anytime when I do something to just the x, it's going to involve a horizontal transformation. Okay, so with that in mind, let's now multiply the whole function by 2. And I'm going to draw in the vertex right here. So for this one, we've got what's called a dilation or a stretch. Either is fine. And it's been stretched by 2 units. And for this, you can see that the only point that's moving is the y number. The x number stays the same, but the y number moves. And that's because I've done it to the whole function, 2fx. I've multiplied that y number, which was minus 1, by 2 to turn it into minus 2. And you can pause and make notes here if I'm going too fast. Now I'm going to actually multiply by just the x number. So I'm doing this one here, where I multiply the x by 2, rather than the whole function by 2. And let's look at the vertex. What's happened here is that I've dilated it or done a stretch by not 2, but a half. So because I've multiplied the x by 2, I've actually done a stretch by a half. Now, if I was to multiply f3x, that would be a stretch by a third. And again, let's look at the vertex. Because it's now horizontally, I've multiplied the x number by a half. So it's doing the opposite of what's in the bracket. Not times by 2, but multiplied by a half. The y number stayed the same. Now we're going to carry on that theme with 2 translations. So what we covered so far, we've covered the reflections and the dilations or stretches. Now we're going to do a translation. And this is where we move the function up or down or left and right. So starting off with adding 3 to the whole function. This will actually, it's like it's moving the function up. It kind of looks like a stretch initially. But if you look at the vertex for the y, it's gone from minus 1 to 2. I haven't multiplied it by a number, I've added on 3, as we can see we're doing in the function here. And I'm doing it to the whole function, so it becomes a vertical translation. Now when I do it to the inside the bracket, it creates a horizontal translation. So it's moving it from side to side. But again, like when I multiplied by 2 and it actually created a dilation by half, this is not going to add 2 and move it to the right. It's going to take away 2 and move it to the left. So here we are, we've actually moved it to the left, even though we're adding on. And again, look at the x coordinate, it's moved from 2 to 0. So I'm taking away 2. So there's quite a few points to take in there, but the main thing, well, 2 main points, when you do it to the whole function, you're doing it vertically. When you do it just to the x, you're creating a horizontal transformation.